Hello and welcome to today's NASA Google Plus Hangout, Observing Earth from Space. I'm Lauren Worley, I'm the press secretary at NASA, and I'm super excited you've all joined us today. NASA does a lot of Earth observations, so that what we learn about climate and weather observation can be applied across different platforms. And we've got a really awesome lineup of folks here to talk about how we do that. So let's get to it. I'm going to introduce them first. With me here at NASA headquarters is astronaut Rick Mastracchio and Japanese Space Agency astronaut Koichi Wakata. Just returned from 188 days on board the International Space Station, and we've got lots of questions about their view of Earth from there. We're also joined by Gail Skorfonik Jackson. She's the Global Precipitation Measurement Mission Project Manager, and she's out at the Goddard Space Flight Center in Greenbelt, Maryland. And also with us today, we have America's weather predicting boyfriend, Eric Holthaus, who's also a meteorologist and a writer for Slate.com. Now, Eric's going to be taking your questions and asking some questions on your behalf. And we really want to engage you in this conversation. So send us your questions to @NASA using the hashtag AskNASA, and we'll get your questions asked to one of our awesome panelists here on the air. So to get us started, I'm going to turn over to astronaut Rick Mastracchio. Tell us a little bit more about his mission, his return to Earth, and some work they did observing Earth from space. Rick?
Well, thanks, Lauren. Yeah, we had a great mission. Koichi and I and our Russian commander, Misha Turin, launched out of Kazakhstan on a Russian Soyuz rocket way back in November, first week of November. We flew up to the International Space Station, rendezvousing in only about 6 hours. We did the quick trip, we call it, and we started our long-duration mission. We did a lot of things while we were up there. You know, the two big things that we're up there for are to do science and research, of course. The other one is maintain the space station. And then folks ask us, what do you do in your spare time? Well, of course, the main thing we do is we look down at the Earth. And we have this great cupola. It's a small room with 7 windows. It looks right down on the Earth, and we have some great views of the Earth.
Wow, awesome. Koichi, anything to add there to open us up?
Yeah, it is. As Rick said, the cupola, the room with the 7 windows, this is our favorite place. We have a lot of work, science, maintenance, spacewalk, robotics, retrieving the spaceship that arrived, but the looking at the window, at the Earth through the windows of the cupola is just outstanding.
Terrific. And we're going to ask you some more questions coming up on that. But let's get over to Gail at Goddard Space Flight Center. And Gail, tell us a little bit more about your mission, GPM, but also the important work that we do observing the Earth and Earth science work at NASA.
Yeah, I'm very thrilled to be here with you today. Our mission, the Global Precipitation Measurement Mission, our core observatory, launched just this past February, and we're already getting some really fantastic data from it, all sorts of precipitation from light rain to heavy rain to falling snow. But there are also 5 other Earth science missions that are being launched right now this year from NASA, different missions. And so NASA's really looking at all different parts of the Earth. We want to understand the Earth as much as we want to understand the other planets. So we have satellites that are looking at ocean salinity. We have satellites that are looking at aquifers and how much water is stored in those aquifers, or how much water is stored in the ice sheets and glaciers. We have satellites that are looking at the land characteristics, whether it be vegetation or streams. We also have satellites that are looking at changes in terms of the water on the Earth's surface. We have satellites looking at the chemistry of the atmosphere. And we have our satellite, which is the GPM mission, that is looking at the precipitation. And we're being able to get measurements all around the globe every 3 hours of precipitation, which is important for science and society.
Awesome. Very cool. Very cool. All right. Well, we've given you an overview of what we want to talk about today. Let's head over to Eric. Eric, I know you got a couple questions to get us kicked off here in our discussion today.
Yeah, thanks, Lauren. And this is really kind of a dream come true for me. I grew up a NASA nerd, just like pretty much every American kid in the 80s, watching space shuttle launches, and I was lucky enough to kind of have the dream of my lifetime to go with my dad to watch the last Discovery launch in Florida a couple years ago, and it's just really like a thrill to be here to talk to astronauts, and And actually, when I was in college, I had a internship with Gail at Goddard Space Flight Center. So I've known Gail for about 10 years, and NASA's been kind of a part of my life since then, following along with these missions. So, just like I think pretty much everyone has this question for Rick and Koichi, but what did it feel like looking down at the Earth from the space station? What kind of emotions were you feeling when you're sitting in that cupola?
Yeah.
Yeah, well, of course, everybody, the cupola, first of all, is a relatively new addition to the space station. And actually, on my last shuttle mission in 2010, the cupola was a brand new module just brought up by the mission before. So we got one of the first views of the cupola on my shuttle mission in 2010. And I had been on a couple of previous shuttle missions. We didn't have that view, so it was a great addition to the space station. It has unprecedented views of the planet Earth below because of all the different windows. You could see for thousands of miles in almost every direction. So it's an incredible view. I think what I always say to folks is whenever you look out the window, you always think, well, I've seen it all now. I've been on 3 or 4 space missions, and I've seen it all now. But every time you look out the window, you see something that you've never seen before. You see something more beautiful than the last time you looked out the window. So I think it kind of gives you a lot of different emotions, but the biggest emotion I have is the beauty of the Earth, the incredible things that we see down here. It's amazing that we try so hard to get off the planet, and then once we get off the planet, we spend all our time looking back at it. It's pretty interesting.
What about you, Koichi?
Yeah, I totally agree with Rick. We go around the Earth every 90 minutes. So, and then during this period of 6 months, we flew around the Earth more than 3,000 times. So it seems the Earth is very small, and it looks very precious with the background of pitch black space. And Earth seems like a small space or big spaceship, I would say. It has a CO2 removal system, temperature control system. If one of those systems on board the space station breaks, it's a lot of work for us to repair. So by flying around the Earth, we really would like to protect this environment of the Earth.
So both you and Rick were active on Twitter when you were in the space station, and I looked back at some of your photos that you took, and it's kind of breathtaking to see that. But what was one view or one thing that you saw up there that kind of changed the way that you think about Earth, or maybe something that you saw that you didn't expect?
Yeah, well, I think Koichi and I probably would agree on this one. One of the most beautiful things we see are the aurora borealis, the northern lights or the southern lights. They are just incredible, and if you're out looking out the window at just the right time, and the sun activity, solar activity, and the Earth, everything lines up perfectly, you get these great waves of green light coming off the planet, and even some red lights, and it's just incredible. And then one night we were out there, and Venus was rising, and the full moon was rising through this aurora borealis, and it was like the universe was putting on a show for Mike Hopkins and Koichi and I, and it was absolutely beautiful.
And the night view of the Earth is impressive, especially in the northern hemisphere. The city lights. During the daytime, you can see the power of nature, like strong winds, beautiful clouds, different colors, and the ocean has different colors of blue. But when you go to the night side, what you see is brilliant city lights, and it really shows the technology of human society and how huge the energy consumption is. And I'm sure aliens, if they see it from outside, you can really tell that this planet is, we have a lot of people.
Yeah.
We're not confirming we've seen any aliens there. Don't ask the follow-up.
Don't want to break too much news here. But Rick, in some of your tweets, I saw that you were trying to take photos of your home state of Connecticut. What did it feel like flying over a place that you knew so well on the ground, and then seeing it from a different way up in space?
Yeah, I did. I tried to take a lot of pictures of my home state of Connecticut in the Northeast. It's very recognizable to me because I'm from there. It was interesting, though. I had flown 3 previous shuttle missions, but all my shuttle missions were in the summer or in the spring. And when I was flying over the planet and flying over the Northeast and flying all over the United States, everything was green and beautiful, and it was easy to recognize, easy to pick out different landmarks in the lakes and things like that. This was my first time being in orbit in the wintertime. And I tell you, it's much, much more difficult to identify things because we use lakes very often to identify and to find places. And of course, when the lakes are frozen over and all the cities are covered with snow, it's not much to look at. So I remember thinking how hard it was to get pictures of my hometown because I looked down and all I would see would be ice and snow and maybe a few rocks here and there. And I was kind of wondering, do people really live down there? So one of the thoughts I had was, well, I'm glad I'm up here and not spending winter up in the Northeast because I know they had a really bad winter this year.
Yeah, we're starting to find some evidence, and NASA's helping study this. But you know, winters, some of the impressions are that global warming is just going to be a couple degrees warmer on average every single day everywhere in the world, and it's not like that at all. I mean, there's unpredictable ways that the planet's changing. So, was there any visible signs of climate change that you could see from space?
Actually, yeah, it's very difficult to see from outside because we take a lot of pictures, but it's it's not a continuous measurement of the actual data. And this is what the Gail and her team is doing at Goddard, and precisely measuring the temperature, distribution of the precipitation, rainfall, and snow and other items, temperatures of the forest, temperatures of the ocean. So. We have this subjective view, but NASA and other international space agencies are collecting those data precisely on a continuous basis to be able to monitor the change in climate.
So we're getting a couple of questions now from the Google Plus audience. One of the questions is, how do you get internet in space to send these tweets down?
Yeah, we do have we have an internet connection. It's relatively new on board Space Station. It's not very stable, and we don't have it for a very long period of time. But that's why actually Twitter is actually really convenient because you can only type in 140 characters, and that's about as much time as we have. Usually, I had 2 or 3 spelling mistakes, and I always had to decide, well, should I go back and fix the spelling mistakes, or should I just hit send because I'm running out of time? So. It's kind of a new thing on board the International Space Station, and and like everything else, we'll make it more and more stable the more folks use it. But it's a great thing, and we used it quite a bit for Twitter and other social media, and it was a great way. I remember many times taking a picture out the window and then coming back to my computer and tweeting and saying, "Hey, here's what's going on right now on board the space station." So it was kind of fun to share that immediate things that were going on.
And Eric, that actually segues really well into a question that we got from St. Joan of Arc 4th graders in Louisiana, and their teacher, Marcy Herbert, who asked us on Twitter, what does a hurricane look like from space?
A hurricane looks like a huge, I don't know, rolling, what is that, how do you say that? It is just, I don't know, huge clouds of swirling, cloud. It is very huge. Even if you have a large field of view angle camera lens, it's sometimes very difficult to capture the entire region of the hurricanes or typhoons, and it's amazing.
Yeah, and the eye of the hurricane is always the thing we're always looking for. Some hurricanes are very, very large, like Koichi said, but the eye of the hurricane is always interesting because you could almost, if it's a good clear eye, you could see the ground in the middle of the hurricane. It's always interesting. One of my missions, we were out doing a spacewalk and flew right over a hurricane back in a few years back, and it was pretty impressive.
So, you travel the world in 90 minutes when you're in space. Is there anywhere that you saw from space that made you want to visit there once you got back to Earth?
Yeah, I have that feeling all the time. I don't know about Koichi, but whenever I was looking at someplace on the ground, and I do this when I'm flying in an airplane, I look down and I see some interesting landmass or something interesting down there. I always wonder what the people are doing down there right now. And that was it was also true when I was on orbit. I took some beautiful pictures of the center of the United States, where there was this beautiful valley and there's a little house in the middle of it, out in the middle of nowhere. And I was wondering what it would be like to live there with that great view. So. Yeah, there's a lot of places I've taken pictures of, and I remember taking pictures of the Dominican Republic, and then about 2 months after I landed, we went down there for a small vacation, so I got to actually visit the place.
And it's very interesting to see the different colors of water. We mentioned that the Bahamas in that area, it's really beautiful, but lakes, some of the lakes have like a reddish color, orangish, yellowish, greenish. It's amazing how colorful the color of the water is throughout the world.
It's probably a question that a lot of those people down there are asking about you. You know, it's the space station has grown in size over the last several years, decade, and now it's kind of routine to be able to see the space station in the evening sky from Earth, you know, as a bright star going past. So. And I'm sure, you know, if people are out there looking for the space station, they're wondering what you guys are doing up there at the same time. So it's kind of an interesting thought to know that you guys are thinking the same thing about us down here. So, so we're talking about we have Gail from who's working on the GPM project, and it launched back in February, I think. Is that right? So. Were you in the station in the position to be able to see that launch, or soon after?
Yeah, we were exactly on board when GPM was launched from Tanegashima Space Center in Japan, but unfortunately we were not able to see the launch of the GPM itself. We saw Rick saw some of the other launches from French Guiana, Ariane 5 launches, but I was not able to see that. Then you know. But I'm sure it would have been really spectacular to see the launch from the space station.
Yeah.
This is Gail. I'll just jump in. I actually was there for the launch, watching it from ground, and it was a very fantastic launch. So it was launched from Tanegashima Island in Japan as part of our partnership, and a picture-perfect launch.
And so when you were on board, were you able to conduct any Earth science that was complementary to the GPM when you were on the space station?
We used the regular photography, still photo cameras, and the video cameras, and also we have high definition cameras located outside along the Columbus module, as well as the Japanese Kipo module. And those are controlled remotely from the ground. You can see the live downlink of the HD image of the Earth, or downstreaming, 24/7 from the space station. And also from the Marshall Space Center, they put together a list of the targets of the Earth observation that we take pictures on. So every day we have several, or sometimes few, targets of the Earth's observation, and we use the regular camera to take pictures. And some of them are like in response to the disaster correspondence. So whenever there is a hurricane, volcano eruption, flooding, and other natural disasters, we were asked to take those pictures, which will be used to show the actual condition that we see from the space station.
So it's kind of like science in real time, then have a human up there and kind of looking for the news-making, high-impact events that are going on every day.
Yeah, exactly. And then in addition to the photo video image that we take, by adding the observational comments or the feeling that we have when we see these events on the Earth, it adds some more, and then obviously this kind of information or comments really attract a lot of attention from the general public.
Mm-hmm. Were you able to see any active volcanoes when you were flying over?
Yeah, we did. I think we saw one down in Central America, a very small active volcano. I know there was previous crews have seen them over the ones in Iceland and other places. We didn't have any real big ones. We did see a few small ones though.
5 years ago, when I was on board the space station, there was an eruption of a volcano from the Far East Russia on one of the islands, and space station crew members were the first of the people or the instruments that took pictures of the volcano of the volcano eruption.
So Eric, this morning we actually had the opportunity, Koichi and Rick, and me too, we got to go out to Goddard Space Flight Center and see the GPM control room out there and talk a little bit with Gail, talk a little bit about her team. And Gail, love to ask you, what did you explain to these guys this morning? Tell us all what they got to see this morning.
Well, we had the opportunity this morning to talk about the GPM mission and why it's important for science and society. You've already been talking about hurricanes and seeing them from the International Space Station. And pretty much you're seeing visible what you might see with your eyes. But with the GPM spacecraft, we have instruments on board that allow you to peer all the way through the clouds, all the way down to the Earth's surface. So when you're looking for that eye wall, you can see exactly where that is based on the observations from the measurements. You don't have to look at the white clouds and try to guess exactly where that eye is. So that's some of the fantastic data that we can use. Also because the global precipitation measurement is actually pretty similar orbit as to the ISS, we're able to see hurricanes as they transition from tropical regions to mid-latitudes. So if GPM were up during Hurricane Sandy, we would have been able to see it go over and into the New York and New Jersey region, which is really important because before the satellites with our capabilities, they only saw storms that went maybe as far north as Tennessee. So we want to be able to see this detailed structure all the way further north. So that's some of the things we're doing. Yeah, go ahead.
Oh, I was just going to say, Gail, this is an improvement over the previous satellite. So GPM was replacing the tropical rainfall measuring mission, which was also a partnership between the Japan Space Agency and NASA. And I think one of the biggest improvements, like you said, for GPM is that now we can see almost all the way up to the Arctic Circle, and we can see snow, we can see those transitioning extratropical cyclones that are impacting more of the countries, Japan and the United States that are the main partners on this mission. So.
And I'll just add, for me, I think the three main contributions from GPM beyond that of TRMM are, one, what you already mentioned, is we're able to get light rain and falling snow. And this is the first NASA satellite mission that was specifically designed to measure rain rates down to 0.2 millimeters an hour, all the way up to 110 millimeters an hour. So that's a fraction of an inch to about 5 inches an hour, and to be able to measure falling snow. The other major contribution is that our footprint, which is basically how much ground do you see with each measurement, is down to 5 kilometers. So that's a 3-mile radius. It's above TRMM, that we're doing beyond TRMM, is that because our spacecraft is so well designed, we can use it to basically unify measurements from all sorts of other domestic and international satellite partners that are already measuring precipitation, but they do it with slightly different capabilities. And so we can unify that so that we get these global precipitation measurements on, like I said earlier, every 3 hours, and sometimes even less than every 3 hours, which is vital for application users, people that might be trying to track hurricanes or start to predict floods and landslides.
So Rick was talking earlier about about his pictures of the Dominican Republic, and then having visited there after he got back. The Caribbean is one of the places on Earth that's most affected by hurricanes. So one of the biggest benefits of GPM that I'm excited for also as a scientist is that we have now near global coverage for a weather radar. So there are a lot of countries that can't afford a nationwide weather radar system like the United States has, and GPM is kind of giving them that capability to have regular monitoring of rainfall, especially in extreme events like if there was a hurricane hitting the Dominican Republic.
That's right, Eric. As you said, if you try to measure precipitation from the earth, from the ground, in the U.S., we have a very strong network of ground radar data that you might see on your nightly news. But if you go to other countries, you go over the oceans, you just cannot put enough weather radars or little rain buckets to actually measure the rain. Mm-hmm. So from the vantage point of space, you can measure the global precipitation. And that data, the data that NASA provides, is freely available to anybody, anywhere in the world that wants to use it. And the other thing that GPM is doing, which is fairly unique, is we release the data to the public anywhere from 1 to 3 hours after it's collected. So this is really important for emergency management that might want to evacuate a coastline for a hurricane or evacuate areas for landslides or floods.
Mm-hmm. So I've done some work in the past since my internship at NASA. I did a project in Ethiopia working with farmers on drought and preparing for possible future droughts with climate change. And is there a way that GPM is helping also? I know that it's talking about we talk about extreme rainfall and hurricanes a lot, but what about the other end of that spectrum of lingering droughts or other types of impacts?
Yeah, so GPM can tell us when it's precipitating and when it's not precipitating, so we can start to determine when droughts occur and also to if need, send food in advance of those. But I think one of the best things, and if we'll play our video, we have a video here of a snowstorm. As I mentioned, this is one of the first missions specifically designed to measure falling snow. And so when this video should be playing, what you're going to see is this is a March 17th snowstorm over the Washington, D.C. area. And with this snowstorm, this is less than 3 weeks after GPM's launch. And you can see that over the Atlantic Ocean, there is precipitation. Is this showing? Okay. Yeah. Well, it's not showing. But basically, the precipitation will be over the Atlantic Ocean, and you'll see these very tall cloud tops. And there will be rain falling out underneath. And that rain will be shown in reds and greens. And then over the land, there will be this really shallow snowstorm, which is shown in blue colors. And what's really important about this snow is that we weren't able to measure falling snow from space before this mission. And many places in the world rely on snowpacks for their spring and their summer freshwater resources. Mm-hmm. So being able to measure both the liquid part of the precipitation and the frozen part of the precipitation is important. And then getting back to the snowstorm on March 17th, I was just told today that this was so early in the mission, and in the D.C. area, 7 inches of snow shuts down everything, and people were told, don't come into work. So some of the GPM mission operators actually had to spend the night before and the night after in the mission operations building with their sleeping bags, because the falling snow really impacts us in a different way than precipitation. Falling snow is harder to remove and other things like that. So if we get that video, we'll show it later.
Sure. So I'm thinking of a place where snow is really important is maybe in a place like northern India or something where a lot of people rely on water for irrigation and growing food. That water from the Ganges River comes from melting glaciers in the Himalayas. So is GPM going to be able to kind of better help places like India prepare for their growing season?
Yeah, it is. I have to admit, it is more difficult to measure precipitation over very mountainous regions, but we are improving those. And so, yes, because we're able to get and measure the precipitation within the column of the data within the GPM measurements, and I'll get back to that in a second, we are able to see the precipitation before it falls. Now, as I mentioned earlier, GPM has two instruments, and the way I like to describe one of the instruments, it's kind of like taking an X-ray through the cloud. And just like a doctor might take an X-ray of a human body and see bones, and some of the bones might be thinner and more translucent, whereas other ones might be thicker and more dense. The same kind of thing happens with one of the GPM instruments, is that you see where there's lots of heavy liquid rain and where there's lots of ice, and it's like kind of compressed through the cloud. We also get the frozen part of the precipitation in that instrument measurement. And then the other instrument, which was actually provided by the Japanese, allows us to see layer by layer within the cloud. And so you can use that information layer by layer to see what's in the column before it hits its ground. And furthermore, jumping ahead and answering a question that may not have been answered yet, we can use that, or asked yet, you can use that layer by layer information to improve weather forecasting models and climate change models, because those models have really simplistic representations of the precipitation layer by layer within the clouds. And so we can use that to not only for our short-term weather forecasting, but for our long-term future in terms of humans as to what's happening within climate change.
So we can have a 3D view, basically, in a way that we've never had before, that will help scientists understand clouds and how clouds convert the moisture into rainfall.
Yeah, that's correct. So the moisture into rainfall, we measure the rainfall part of that, and we have a three-dimensional view of it. And earlier you were talking about climate change, and most people, most humans are not really going to be impacted by a 1 degree change. They're put on a. But really, one of the things that I'm not a climate scientist, but the climate scientists are saying that precipitation extremes are going to become more extreme.
Yeah.
So where there's drought, there'll be more drought. Where there's heavy precipitation, there'll be more precipitation. And we as humans, because water is essential for our life, we're going to probably feel the effects of climate change more in precipitation patterns than in temperature patterns.
So GPM is kind of the GPM is the start of a whole suite of new NASA satellites this year that are helping to answer that question of how is the Earth changing with global warming.
Yeah, that's right. NASA has many satellites that are looking down at Earth to measure all sorts of things. It tells us many different aspects of how our Earth system works as a whole. Without the satellite measurements, it's like maybe having the edge of a puzzle filled out from ground measurements. But we can start to fill in the middle of the puzzle by using all these different satellites to tell us different components of the Earth system and how it works together.
So we have a question from Twitter from Samantha Walter. How much free time did the astronauts have to sit and look at the view of the Earth on the space station and kind of watch these changes, or watch the weather, watch these fascinating aspects of nature float by below you?
Yeah, we don't get a lot of free time. Our work day is pretty packed. We exercise for 2.5 hours a day. We work for many hours a day, and then we have to eat, of course. Usually there's about maybe 2 hours at the end of the day that they call our pre-sleep time. This is where we'll eat dinner. This is where we'll kind of wind down, do a few emails from home, maybe phone home. And that's where I always like to spend time looking out the window. That always seems to help relax me. So we get a couple hours to look out the window. And of course, it's very dependent on our trajectory. We may be spending a lot of time over the Pacific Ocean at that specific time of the year. So it really depends on our trajectory, what you get to see.
So another very important related question is from Twitter. Is there coffee available to keep you guys going during all these marathon work days?
Yeah, definitely. We have tea and coffee, and even I love green tea. And then we have different kinds of beverages, just water, orange juice. So and it's really good. And then on board the space station, as I always say, we turn yesterday's coffee into tomorrow's coffee. Because water for the usage on board the space station. Water is a very precious thing on board the space station, not only on the ground.
Yeah, and that's one of the challenges, now with the drought in California and other impacts of climate change that we're seeing this year. We're starting to think about water as a more precious resource than maybe before. And there's actually some places in California that are starting to implement this kind of water recycling on a citywide scale that NASA has helped to pioneer some of this technology. So they'll get to drink their coffee the second day too, maybe. But so
we're going to take a few more questions. We've only got about another 5 minutes or so, so maybe we can do some like lightning round questions from Twitter and Google+, so we make sure to get to everybody's questions here.
Great. So we have another question from Twitter and I think this question is for Gail as well as Rick and Koichi, but this Twitter is from this tweet is from Savannah, and she says her dream is to work at NASA and specifically on the ISS. So what's the best way to make that dream possible?
Well, I think Koichi and I kind of tell folks who want to work for NASA or become astronauts, we tell them the same thing. You have to find something you really enjoy. You have to find, whether it's being an engineer, being a scientist, or being a doctor, or being a pilot or a test pilot of some kind. Find something you really enjoy and get really good at it. And if you enjoy it, you're going to become very good at it because you enjoy doing it, and you're going to practice it, and you're going to become great at it. And then, of course, apply to NASA. NASA needs all kinds of folks. I worked at NASA as an engineer. I worked as a flight controller, mission control, and now I work as an astronaut. So there's all kinds of great opportunities at NASA, and I never thought I would get to where I am. So if I can do it, many folks can.
This is Gail. I'll just jump in. Take the hardest math you can, or if you don't like math, I tell some middle school girls, and our astronauts will confirm this, that they need seamstresses to come up with better astronaut suits. And they need chefs to come up with better meals. So, there's all sorts of ways to work for NASA.
Yeah, it's not just about math and physics. I think that NASA does so many things now about, I met, when I was an intern at NASA, I met an archaeologist that was working for NASA. So almost anything that you can imagine, NASA is working on it. So, what about you, Koichi? What was your path to become an astronaut?
Yeah, I dreamed of going to space when I was 5 years old when I saw the Apollo lunar landing, but at the time I thought it was beyond my dream because there was no Japanese astronaut at the time. Only American astronauts and the former Soviet Union cosmonauts were working in space. But I had a strong desire to build or fly airplanes, and then I became an engineer of an aircraft structure. And then I saw on the newspaper that Japanese Space Agency was selecting astronaut candidates, and then applied. I was luckily selected. So if you dream and if you try to reach the goal by studying harder, there is a way to go beyond what you think that you can dream of. And so I think everyone watching this, all the students, each one of you has something that you can do very well and do probably better than anybody else. And then from that, please continue your dream and then aim high, and then probably you will be working with us on board the spacecraft.
Well, I think that's a great place to leave it. Thanks, Lauren, for organizing this, and I think it was a really amazing, for me personally, dream come true to have this conversation.
Thank you, Eric, and thank you everyone who joined us today on NASA's Google+ Hangout, Observing Earth from Space. I want to thank our celebrity questioner, Eric Holthouse from Slate.com, and Gail, whose middle name I will never get right, is Gail Zutronic Jackson, who's the Global Precipitation Measurement Mission Program Manager from the Goddard Space Flight Center in Greenbelt, Maryland. And of course, my esteemed panelist here at NASA headquarters, Koichi Wakata from the Japanese Space Agency, and Rick Mastracchio from NASA, who just returned from 188 days on the International Space Station. You don't have to leave the conversation here, though. You can continue to engage with us. You can follow up on this discussion on our Twitter account at NASA and the hashtag @NASA questions. And of course, we're online. We're on Facebook. We're on Google+, and on a NASA television channel near you. So, on behalf of everybody here at NASA and these guys, we want to thank you all for joining us today. Enjoy the rest of your day.